All right, welcome everybody. It is 4 o'clock in the afternoon, and we're about to go drink in an hour. So I promise to be brief no matter how long it takes. So I want to talk to you a little bit today about CarTwin and where we're at today and kind of how we got here. So our parent company, Big Rio, about 5 years ago, we started working with a major OEM, one of the biggest OEMs in the world. They came to us with a unique problem. They said, you know what, our dealership technicians are struggling to diagnose vehicles because they're becoming so complicated. The systems are interconnected and they rely on so many sensors, they're misdiagnosing the vehicles. So they said that is causing warranty repair costs to go up a lot. It's also causing customer dissatisfaction. Do you think you guys could use the data within the vehicle to diagnose the vehicle and tell the technician what failed? So in other words, instead of giving them, say, an error code that just says, oh, there's something wrong in your air spring system, tell them exactly what failed. We said, yeah, we can do that. So we did. And it was very successful, over 90% accuracy. Then we also included in that, for all the other components within each one of the systems, we included the relative health or the probability of failure of each one of the other components so you could see the health of your vehicle. Wouldn't it be great to know what's about to fail? So that brings us to this question. What do you actually know about the health of your vehicle right now? And of course, CarTwin is really focused on fleet vehicles and fleet systems, not so much the consumer side yet, hoping to be there. But when you think about your car, I'm talking about the things that are gonna make it stop on the road. The things that you're gonna get out there on the road and all of a sudden you're gonna go, darn it, I've gotta pull over, or my car stopped working. I mean, you know what the oil, there's oil pressure, you probably got some temperature gauges, maybe a voltage gauge, but there's only one item that you can predict the failure of your vehicle. And it's the same as it was 70 years ago, and that's your fuel. You know how much fuel you got in the car, and you know that if you run it till the fuel's out, that car is going to stop. Everything else is pretty much a guess. I mean, think about it. What if the fuel, we were given the same indications for fuel that we were given for everything else? You'd be out on the road, driving down the road, and all of a sudden you'd get a warning that said you're out of fuel. Not good. So not much has changed. 70 years ago, and I used Hudson because Hudson came up with what they called the idiot light 70 years ago. So basically on a Hudson, you could see the temperature and you could see the pressure and you could see the fuel level, and you even had the little idiot light that would tell you you've got a real problem with your engine. It wouldn't tell you what it was, but it'd tell you have a real problem. Now when I bring these things up, I'm not trying to suggest that there haven't been amazing advances in automotive technology. There have. I mean, if you sat in on the last session, I mean, for goodness sakes, pretty soon there's going to be a country song where the guy's truck leaves him too. So it's been amazing what the advances have been. However, for those of us that are trying to either run fleets or run our vehicles and understand ahead of time what's going to fail on those vehicles, it's a challenge. So the real problems as we've gone down here, and I'm going to go through these with you and just kind of talk with you about them, but GHG reporting and reduction. What are the real emissions coming out of your vehicles? What are the real emissions as the car goes through its different cycles and they change? Whether a vehicle's idling, whether it's at speed, whatever it's doing, your GHG emissions change. Our system tracks that data and we can give it to companies and we can help them understand how much GHG they're actually emitting, as well as options to be able to reduce that. The second thing, obviously, on-road breakdowns and downtime. For fleet companies, on-road breakdowns are huge. It costs you 4 times more to fix something when it breaks down on the road than it does if you just have it happen in your own shop. So that's huge. And the third thing is repair time. And again, this kind of goes back to what we were talking about with diagnostics, where technicians are misdiagnosing items that fail in a car and they're replacing the wrong parts. The opportunity is huge. Okay, so we're looking at, from a CarTwin perspective, we're looking at a couple major items. First of all, the ability to help a company truly report what their greenhouse gas emissions are. And for those of you that aren't completely familiar with it, you have different scopes of emissions. So the first one is scope 1 emissions. Scope 1 is really, this is how much greenhouse gas my fleet of vehicles are emitting, doing whatever it is I do. So that's just kind of an in-house number. These are our greenhouse gas emissions. The second piece are what they call scope 3 emissions. So let's say, for instance, like we have a POC going with a cement company. Let's say, for instance, you have a customer that's building a building. They need to know from a scope 3 standpoint, how much greenhouse gas did you emit bringing cement to my building? Well, that's a much harder question, because not only do you have to know the exact vehicles and how much greenhouse gas those vehicles put out, but during the time that they were working on that building. Again, because of the way that we use our devices and our data logging capabilities, we have the capability to give them that information. It's huge. The third thing, or second thing, is really connecting the vehicles to the management systems. It's not going to surprise anybody in this room to learn that the majority of companies are still managing their vehicles on spreadsheets. A lot of spreadsheets, and look, I'm guilty too. I use a lot of spreadsheets, but you know, you think about how complicated these vehicles are and how expensive they are today. They deserve more. And one of the things we do really well is to connect that vehicle to their management system for all the data. So there's no longer any need to run out to the truck every week and write down the mileage and get the run hours. So we can do all that stuff. And then finally, certainly predicting breakdowns and failures before they happen. Our secret sauce, I already gave it away. It's really utilizing the data within the vehicle to build machine learning models, to build a cognitive digital twin for each one of the systems, and then utilize that digital twin to predict breakdowns and predict failures so that they can maximize their uptime and maximize utilization. Okay, so this is some really interesting data. This was with one of our POC projects, and one of the things we did here as we tracked their vehicles over time is, you can kind of see there on the left, the bottom scale on this one is the RPM that the vehicle was operating at. And you can see that they spent a lot of time at 600 RPM, that's idle. So they're spending an enormous amount of time at idle. They're also sending out an enormous amount of carbon dioxide, a lot of greenhouse gases at the idle state, significantly more than the other states. And so utilizing and helping them with this data, we then start to look at what they're doing, and we start to say, is there a way that we can reduce your greenhouse gas emissions? And when you look at this, this is just a little bit, 2/3 of the total engine time at the idle state. So then question number 2 is, what are they doing at the idle state? In this case, it was cement trucks. Certainly there are times when they have to idle to let the drum run so that the concrete doesn't get hard. But what we discovered is, by tracking them with utilizing GPS, we limited out any time that a truck was sitting at a job site waiting to unload, or sitting at a batch plant waiting to be loaded. And then we calculated all the other times that the truck was just sitting there idling, and it was significant. So we were able to save them a significant amount of not only greenhouse gases, but fuel. A lot of fuel is being spent here. This is just an example dashboard with our carbonless products. We have a dashboard. This is fully customizable. We hook our systems up to their vehicles. We're able to download their data and give them a dashboard, or in a lot of cases, we give them, connect the data to their management system. We connect it to their ERP, and God forbid, but we give them spreadsheets. This is just giving you a rough idea of the reduction potential that we were able to obtain using idle timing, routing changes, not so much in the routing changes, they were actually pretty good at that, but certainly the mechanical condition and breakdown avoidance. And for 100 trucks, that equates to almost 3,000 tons of carbon dioxide in 1 year on 100 trucks. That is significant. So as you can see, I mean, there's a pretty substantial case here that our technology can really open up data and make it available. For those of you that may be trying to calculate your carbon dioxide emissions right now, it's probably a guess. It's probably based on fuel usage. I think we were using this fuel. This is about how much we're going to use. We can tell you exactly. Okay, so this is the machine learning innovation with regards to avoiding breakdowns. So I want to take you through this because this is a really great chart. The gold line that starts at 80 and goes down close to 0 is the overall health of this particular system. The purple and green lines represent two components. Now the reason this is great is because when the technician made the repairs I'm about to talk about, he didn't have this data. The technician didn't have this. So what you can see here is component B, which is purple. You can see the predicted probability of failure starts out in this particular data set at about 20%, and then it moves up to about 40 around 2016. Well, at the same time, component A is got a low probability of failure, but you can see something happened in 2016. There was a failure in that component. Now, I will tell you that, like I was saying earlier, most of these systems, these components don't operate independently. They operate together. One requires the other. So you can see the failure in 2016 on component A, the green line, and it continues to get worse over a period of time. Well, finally, around 2018, a technician goes in and diagnoses the system and says the problem is component B, the purple line. We need to replace that. Okay, if you would have had CarTwin, you could see that it was actually component A that was the problem. And this is honestly more common than you would think because things like batteries being replaced when it's actually an alternator, O2 sensors being replaced when it's actually a vacuum leak. There's a lot of examples out there where good technicians misdiagnose a system based on symptoms that they assume are operating independently when they're not. And finally, when we did our first work for the OEM, it went all the way to the director. And he was really excited, and he said, "This is really fantastic. You guys have hit something here, but you're looking at the wrong things. You need to look at batteries, because batteries, particularly as they relate to electric cars, are going to be the key factor for OEMs to be profitable. If the batteries go bad, the vehicle's not profitable." So what we did was we started to look at the batteries, and we started to look at a number of the different factors related to those batteries, and we came up with what we call the battery aging metric. So this has nothing to do with the state of charge of the battery. This is the health of the battery. And as a matter of fact, it changes depending on what the climate of that vehicle is operating in. So cold climates versus warm climates, you know how that plays on batteries, as well as how the vehicle is being charged, the charge cycle. Do they plug it in every night? Do they not plug it in every night? And so we can utilize this information to provide feedback to owners and fleet owners to say, hey, you might want to alter your charging cycle or do something to help prolong the life of your battery. I know that was quick. Thank you for your time. Are there any questions? Yes, sir. Great question. That's a great question. So we partnered with a company. I didn't want to build hardware. So I didn't want to get in the hardware business. So we partnered with a company. And as a matter of fact, one of the big challenges that we had going to do this was when we were working with the OEM, we got all the data. So that was an easy thing. But when we go out and do this by ourselves, we got to go get the data off the vehicle. So we had to have a data logging tool. Now, you guys are probably all familiar with telematics. So telematics is really a very simple little device that plugs into the ODB2 or you know, some of the other plugins on the vehicle itself. But they're not programmable. They have no onboard data, and they're really not able to get the types of data that we really need, because we need lots of data and it has to be very rich. So we started a search for data logging, programmable data logging devices. And I was getting really discouraged at the beginning because the price points were coming up like $9,000, $10,000, we finally found a partner that I can do this. I can do this for, from a hardware standpoint, about $400 a vehicle. It's a fully programmable data logging device. Takes about 20 minutes to install, and that's if you're trying to put it behind the dash. And it's got onboard memory. I can also connect it to Wi-Fi to download via Wi-Fi or 4G, depending on the data that we want. So it's really a neat little device. Our website is going to be updated here very shortly, and we're going to start selling those devices to not only fleet companies, but I think the racing community is going to want some of that as well. So we'll see. Anybody else? Good question. Thanks. Yeah, good question. So in order to make the machine learning models work, it's not a simple function of just downloading the data out of the car. It's really important to integrate that with the maintenance data that's happened to the car to update the machine learning model. So like, let me go back for a second. It's like in the case that I showed you, let's go back one here. Okay, so in this particular case, you'll see in 2016 and 2018, the data in 2016 on the component failure of component A, and I'll spill the beans a little bit. Component A is a compressor, and component B is a damper. Okay, this is part of an air spring system. And the technician thought it was the damper that went bad. It was actually the compressor. So in order to have this data updated and correct, in 2018, the data that the damper was replaced came out of their maintenance system. We had to have that data. So in order for us to build accurate machine learning models, we have to have failure information, which usually we can get from the car, but a lot of times it comes from the vehicle or from the maintenance system, but certainly repairs and maintenance, we have to have that as well. Great question, thanks. Yes, sir. Yeah, so what we're doing right now is, like for instance, one of our POCs, they have Cummins engines. So we can build a model that's unique to a Cummins engine for, say, the emission system or the turbocharging system or the fuel system, okay? And then instantaneously, I have a model that will work for pretty much anybody else that has a Cummins engine. It will also be very close, if not at least 80% accurate for another similar type engine in a vehicle. So I hope that answers your question. It wouldn't, which is part of the reason why, another reason why we focused on fleet companies, because they tend to have a similar, large number of very similar vehicles. It's what makes sense for them.